Good evening to everyone. And yeah, before I begin our today's session, I really want to know how many of you here already familiar with Python programming. You can raise your okay. Okay, great. Okay, thank you all. Thank you. Okay, guys. So let's get into our session. Let me share the screen. Okay. Okay, guys. Everyone able to see my screen? Yeah. Okay, great. Okay. Okay, guys. Let's begin our first open session, and there will be three open sessions in this combined. So this is the very first one, and in this first one, we are going to introduce Python programming. How this Python programming used in space applications, and first of all, why this Python programming is famous, why everyone really want to learn Python programming, and how come this is getting into space domain, how come this is enriching space domain, okay. And how come this is helping the AI domain. We will be checking that also end of the today's session. And when I mean, if you are learning Python very well, and if you are applying Python into space domain, how you can get yourself into, I mean, to start a space tech career. Okay, that's what also we will discuss. So once this is done, we will get into coding part. So I will be walking through a code where we will implement one simple image processing task, okay, totally related to aerospace. We will be doing a simple task. With that, I wind up our today's session. So this is the agenda, the whole agenda of yeah. Okay. Right now, is it better, Arjit? Yeah, the headphone was hanging. It was near to my mouth. Okay, sorry for that. Okay, guys, once again, I am repeating the agenda of our today program. Start with Python. Okay, why this Python is pretty much famous, and how come this Python is getting its hand into space tech applications, and we will see some examples in space tech applications. Then we will check the career opportunities if you are able to get good experience in Python with some good hands-on projects, how you can start your career in space domain. Once this is done, we will jump into a coding walkthrough. I will be walking through each and everyone into a code session where I will be showing you how a simple image processing stuff related to aerospace is working out with Python. Okay, so this is the agenda of our today's session, and there will be two more sessions. Okay, where we will discuss how exactly data science, AI, ML is helping the space domain, and how exactly we can start our career in AI. Then in the last session, we will be discussing about how exactly we use Python, AI, ML in satellite imagery part. Okay, it's entirely related to image processing. So please attend all the open sessions and get enormous knowledge. Feel free to raise your doubts, whatever be it. Feel free to raise it and support us. Okay, that's it. Let's begin, people. Yeah, first of all, Python programming. Okay, so it wasn't there initially. Okay, to be honest, it wasn't there. Everything was evolved with R programming. Okay, people started to use R programming a lot in data science based applications. Then all of a sudden, this Python got into hand. And because of its simplicity, because of its easy to understand ability, flexibility, user friendly, and so many frameworks already evolved. Okay, because of its simplicity and its open community based one, so anyone can use the Python to build outstanding stuff, awesome stuff, and anyone and each and everyone releasing it as an open source. So when it's a open source, everyone can use it. Everyone can use it to produce their own product, own projects. Okay, so that's how Python got famous because it's super open community based, and so many packages already evolved. So many packages out there. If you take out any domain, okay, to be honest, if you take out any domain, medical domain, astronomy, or finance, a business, a data visualization, whatever be it, if you take out any domain, everywhere we can use the Python. Coming to web development, okay, people are nowadays mostly using JavaScript for the front end applications, but we have packages, we have frameworks to develop front end also. Now to compromise the API services also we have Python packages. Okay, so it's quite beautiful, it's quite easy, and everywhere people are using it. The scalability is also good. Initially there was a problem how to scale the Python applications into production. Okay, initially there was a problem when Python was getting famous. There was a problem how to scale the Python applications for production, how to make it available for vast group of people. Okay, it was the problem initially, but that problem now sorted out. Python is not a lazy program. Okay, it's a very super fast program. Lot of flexibility is there, super friendly. Syntax is very easy to understand. Whoever really want to start can spend at least just 1 month or 2 months to have a good experience with Python alone. I'm not talking about the applications and projects. If you want to start a Python, okay, if you want to know what is Python, you need to spend minimum, daily 4 to 5 hours for 2 months for the Python. You would definitely get the complete idea about the Python. Okay, that is how Python is easy to understand. That is why Python is pretty much famous. And like I told already, very easy and simple, efficient. This is really important point, people. Diverse libraries and framework. Diverse libraries and framework, very important point. And vast communities using it, highly portable. And you know what? If you take out any package in Python programming, the perfect documentation you can get. Okay, the package provider itself giving you a documentation, or you can find the best examples quickly all of a sudden in YouTube somewhere. Okay, so already people are made it highly resourceful for the open community. So for these reasons, Python is the most wanted popular language. Okay, you can stop me if you have any doubts, no issues. And coming to companies that use Python a lot, okay, and I am a industry guy. I am currently working as a machine learning engineer, senior machine learning engineer. So our application entirely involved with Python programming, just Python programming. We build the backend with Python programming where we apply the intelligence, AI, and we build the front end for it, and we like attach the backend with the database, and we attach the front end with the API. So everything we are doing and compromising, as well as scaling, as well as like deploying, even deployment, coming to containerization also we use Python a lot. So it's quite simple and very important. It is getting used even in industries in a very broad level. Here I named just few industries are using Python a lot. So you know about the Google. Google introduced the Bard. It's a data science product. Python was there. And Netflix. Okay, Netflix is a networking company. Okay, okay, networking company, broadband company, they are using Python, okay, and they are using JavaScript also. And this Facebook is a social website, right? Social service, and they are using also. So each and every company, software company, research companies are using Python as a predominant tool. The predominant tool. That is why people are instructing and forcing the youngsters start with Python. Okay, thereby choose a domain and start with the Python, develop beautiful projects, getting get some job and get a good life. Okay, that's how the trend completely changed nowadays. For these reasons, Python is pretty much famous. Okay, yeah. And coming to space applications, yeah, I really wondered how come this Python is helping the space application in initial days before even I got into this domain, the space tech domain. I wondered a lot because I started my career as a lecturer. I was entirely belonging to aerospace. Okay. I started my career as an ordinary lecturer. Then I got into university level lecturing. Then only I got into this data science. So initially, when I started to look this Python, I didn't think about these Python applications in aerospace, in space tech. I thought of using the Python to get into some software jobs, kind of that. All of a sudden, I realized, okay, Python is the predominant tool getting used in space applications, and it is trying to replace the MATLAB. Okay, trying to replace the MATLAB. Both MATLAB and Python coming with oops. Okay, they were used MATLAB a lot previously, but nowadays people are using Python because it's so simple. You don't need to write the functionalities from scratch. People already wrote, and it is given to you as an open source. You have to just fetch in. You need know you need to know how to use it. Then you have to fetch it. Then you have to put it into your applications. So that's how the simplicity of using Python in space applications nowadays becomes. Okay, and the product value, the project value, what we are producing, meeting the demand a lot and lot. That is the beautiful thing. Less effort and very cost outcome. Okay, luxurious outcome. That is all about this Python, especially in space applications. I'm not blaming the other domains. If you take out the medical domains, if you take out stock domain, finance domain, and any other digital services, okay, everywhere people are using Python predominantly, but the luxurious product, okay, the luxurious product we can build only in space tech and medical tech. So they are using Python a lot and lot. So for all these reasons, we have to learn Python if we really want to have a good life in future. And coming to space, why this space is very 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 important. Okay, we do have to explore this space. Okay, we are living safe and sound in Earth, and we are given with everything, right? So we are enjoying the digital services. We are enjoying the the modern era, digital era. There's nothing wrong with that. Okay, why unnecessarily we have to explore the space? Why unnecessarily we have to get into other planet? Why unnecessarily we have to initialize the Mars colonization? So these are all the really important question, right? But there's a story. See, our ancestors, okay, our ancestors had done tremendous work, okay, some decades before. Because of that only, as of now, we are enjoying this comfort. They involved into space research a lot and lot. Okay, don't take very very old example, starting with the NASA programs. Okay, so NASA initialized in the range around 1960s. I guess it's right. In the period around 1960s. Okay, so they started to spend a huge money on it, and they established a beautiful research lab, highly sophisticated lab. They did world class experiments, and they found these orbital mechanics. They found rockets working. They fine-tuned these spacecrafts. Okay. They started to produce the internet all over the globe. They started to produce the cloud networking all over the globe. So whatever they researched for the betterment of space tech only reverted back right now to ease our comfort. We are comfort. We are getting comfort. We are getting everything at this time in our life, right? In the name of digital services. So everything is given to you because people worked some ages before, only focused towards the space. They really wanted to explore the space, so they had to build very, very sophisticated high technology instruments. They had to go through very highly innovative technology. Okay, because of that only nowadays we are experiencing these comfort people. Okay, so if we do not work right now to fulfill the need what space research need, okay, definitely we will be diminished in all these digital services. We wouldn't able to keep up the scale, keep up the slab. Okay, we will definitely come down. Okay, that would be pretty much unfortunate, and intelligent peoples won't allow that. Okay, we are all intelligent peoples. We have the capability. Okay, we have the capability to work smart also, so we definitely won't let that happen. That is the story, inspiring story with the space tech. This is how we human beings are getting benefit. And another important thing, coming to planetary defense. So we successfully established a DART mission. We are now capable to send rovers and yeah, flight objects, flight vehicles to the deep space. We are taking images. Okay, we are getting artificial images aboard the deep space through the telescope. So we are in well advanced, and we are also getting benefit due to that. Okay, so is it in? I mean, this is definitely interesting. Okay. So everyone really want to have a career in space technology because this is just beautiful. And Python is the tool. Python is the tool to start off our career in space domain by doing simple projects and strengthening ourselves in the skill set and approaching for the interviews, approaching for the higher educations, approaching for the bachelor studies. That's how we have to place our seed in space tech companies in future people. Okay, this is the small story between Python, AI, and space applications as well as space tech. I guess there is no doubt as of now. You can stop me anytime you want. You can clarify any doubts anytime. Okay. Now let's check out few applications. Okay, let's start with this framework. What is this? Data analysis process. Okay. Don't worry about anything. Just focus this data analysis process. So what is this? See, it is starting from data requirements and specification. Starting from one second. It is starting from data requirements specification. What do you mean by data requirements specification? Imagine you want to have a decent images. You want to have a decent images about the Mars, for example, from a database or a data warehouse already there. You want to have a decent images about the Mars from a data warehouse what is already there. A data warehouse will get these images from a space survey. That is a different story. I am not getting into that story. I am starting with data gathering. If you want a particular data, you have to collect that data from a source. That source is nothing but data warehouse. Could be a server, could be a database, could be elastic network, whatever be it, could be a search engine, whatever be it. So you have to have a data, first of all, from a population. You have to have the sample from a population. Okay, that itself we cover the step 1 and step 2. Then coming to step 3, what we are doing, data processing, and step 4, we are doing data cleaning. So data processing and data cleaning. So once you got the images, whatever you want regarding the mass, then you are going for data processing and data cleaning. Okay, what if the images you are getting is not in a good visualization? It's not providing the information. What if you need to process a little there to extract the insights? Extract the insights. What if you need to remove the noises, distortions out there to extract the insights? Okay. So once you got the data, here our example is a mass images. Once you got some mass images, next you have to do some pre-processing. You have to apply some cleaning there. Then you will have the cleaned image, the right data. When you get the right data, next you have to do the data analysis. You have to do the data analysis. What do you mean by data analysis? The similarity between the two images. For example, you are getting the images from a Mars aboard the rover movement. For example, rover movement. There are 5 images. There are 5 images. Each and every image is having the rover moving in different points. Okay, so you are doing the data analysis there, and you are plotting which image is where the rover is starting its journey, for example, and which image is where through rover is moving, and which image is where rover is doing the final spot. Maybe something like a route map connection. Okay, something like a distance calculation, so that you can do. This is called information extractions from the data. So when it comes to getting the complete details about the rover movement on a Mars, you need to have a couple of images, frames, or you need to have a proper video. If video you are not getting, you will be getting any images. By looking at the elevation of the images, you can make sure over different frames how the rover is moving from one point to another point. This is how you are validating the rover movement, and you are making sure rover is healthy and fulfilling the exact objective. So this is how we are like dealing with the data and extracting the useful informations, thereby getting the insights, thereby fulfilling our requirement. And finally, coming to communication, it's nothing but the outcome you are getting from your data. So this is called data analysis. Here we took an example of a Mars image. There are so many criteria. If you take out some business information, I mean some business statistics, so it's a very how confounding data. For example, very confounding data is there, and you are getting the samples out of it. You really don't know what is out there. Then you have to do all this data processing, data cleaning, data analysis. So these are all nothing but pure statistics and some strategies. Okay, how to adapt those statistics in a strategy to develop an algorithm. So here we use Python a lot and a lot. This is how Python got famous. People started to use Python initially in data analysis. They haven't used Python as a backend. They haven't used Python as front end. They started to use Python in data handling. And then Python got itself into all domain. Okay, that's a different story, but this is one of the very interesting area where we use the Python a lot and lot. Okay, now coming to very peculiar aerospace application, that is nothing but remote sensing, GIS, geographic information system. Remote sensing and geographic information system, right? So what is this actually? We are investigating the details on our Earth surface. Thereby we are able to detect what is happening there. The weather changes, the minerals detection, okay, and some deforestation identifications, and some spy kind of thing. So we can do anything, right? We are monitoring the surface of the earth. We are not only monitoring surface of the earth, we are monitoring what is happening within the earth, the movement, the fluid movement. That also possible by remote sensing to understand. We are able to understand it just by analyzing the images. That is possible. We got this far nowadays. So how is this possible? We are quite capable right now to send a satellite from, I mean, through a rocket to a orbit, and we are making sure whether the satellite is following its trajectory in the right way. If there is any obstacles, how it is getting across those obstacles, we are very good at that. So we learned the gravity. We learned the gravity very well, and we learned how these imaginary orbits are made. That is pure astrodynamics. We learned it very well, and we are sending satellites from the ground to there. That is doing this job for us. How it's doing it? It is collecting enormous data. It is collecting enormous data. So that data is processed at first in a processing station. So the data compression and transmission is happening here. Data compression and transmission is happening here. So this data, what is getting received from the satellite by the processing station, is known as telemetry data. Okay. So this data is very, very humongous in petascale. You really petascale. It's a huge, it's a large scale. Okay. So not all the data carries the information. We need to know how to connect those informations, how to extract the right data. So we have to apply the ETL process. Then we need to get the right data. Then we have to do the analysis, proper analysis. Thereby, finally, we produce the GIS applications. GIS application is task oriented or objective oriented. If you want to look the deforestation alone on a particular region, it will just look the deforestation alone. If you want to find the fish clusters on the ocean, it will just focus on the fish clusters. So that's how we build GIS softwares. You know how much these GIS softwares values nowadays? Okay. If you know how to develop GIS softwares by yourself, you got the job. Okay. You got your luxury life. That's all about it. That's how, I mean, that is the beautiful thing. There's Python and data science as well as the space domain embodies. Okay. Yes, people. This is an amazing example where we are using Python a lot and lot. Any doubts, you can just stop me and clarify it yourself. And this is another area, people. Python is extensively used to analyze space mission data also. What do you mean by space mission data? How come this differs than remote sensing data? So this is entirely against the remote sensing. This time we are not like taking the images from the Earth's surface. This is all about space mission data. This is again different than astronomy. Astronomy is all about space survey data. Okay, space survey data is different. Space mission data is different. So what do you mean by space mission data? So we are sending flight vehicles to the deep space. We are sending aircrafts for a commercial purpose. We are using military jets for a security purpose. We are sending spacecrafts for a probe, for a deep space analysis, object analysis. We are using satellites all over the globe. So these are all known as flight vehicles. So these flight vehicles are highly autonomous. No one is sitting there and piloting it. No one is piloting the rocket. A rocket is getting launched from the ground by autonomous. Everyone is having the control, but the main control is in the hand of digital computers of the rocket. That is known as control systems. So control systems are taking the informations from instrumentations and analyzing those informations, and based on that informations it has to understand what is its current state, and it has to take the decision what must be the next state, the stability criterion, the stability rectification. If anything goes wrong in the stability, it has to find itself that something is going wrong, and it has to find the right way to get back to the right path, the determined path, the pre set path, right? So it has to analyze the enormous data. Yes, yeah, it has to. Any doubts?
So
My mic. Okay. Okay. Is it better now? Okay. Mm. Yeah, stop me for such cases. Ajit. Okay, guys. So, mm, yeah, I got it. I am checking the slideshow. Yeah, here it is. Yeah, I was. Yeah, okay, it's fine, people. So I was telling the control systems, right? So you know what? It is. I mean the rocket's control systems, which is nothing but digital computers. So it has to analyze a huge data, the data taken from the electronic instruments, and based on that only it has to find itself whether it is in the right track to reach the goal, to reach the payload delivery. Okay, it's not just about rocket. If you take out satellites, if you take out deep spacecrafts, if you take out rovers, okay, if you take out, I mean, if you think about the rover discharging, everything is highly autonomous. So the control systems has to deal with enormous data. So this is called space mission data. This is called space mission data. So there's a difference between space survey data, remote sensing data, and space mission data. Okay. So to handle this space mission data, in order to aid the control systems, in order to aid the trajectory optimization, in order to aid the terrain relative navigation, as well as flight navigation, we need to we need to deal with super smart systems where we use Python. Previously we used MATLAB there. Okay, previously we used MATLAB there, but nowadays we are using Python a lot and lot, and introducing intelligence there in those control systems. Python is the record one. Introducing intelligence, I mean AI. So these control systems are getting tuned nowadays with AI. So imagine without Python, is it possible? No. So this is how Python got itself into the space mission. Okay. Yeah. And here I elaborated whatever I given. See, trajectory planning, trajectory planning, navigation, control of spacecraft is where we use the Python. And we have the Python frameworks such as Pygame, Piglet, Pyglet, PyOpenGL, which are, I mean, these packages are helping to create simulations. Just like how you are doing the simulations in MATLAB, you can use these packages to do simulations where you can draw, or you can define your object, your spacecraft object. You can set the entire environment there. Okay, you can make your object to learn the environment and getting the autonomous behavior. Everything we can do. Everything we can do. Whatever we have done with the help of MATLAB, nowadays we started to use Python. We started to replace those functionalities with Python. Okay. And coming to this, the Python frameworks. This is web development framework. There are so many frameworks. Here I mentioned just two because these are predominant: Flask, Django. You can count Fast API. You can count Bottle. You can count another one. The reason the one Streamlit. Okay, these are all the web application frameworks. So these frameworks are used to produce softwares which are helping the status monitoring, command interface for ground control operations. This is where also we are using the Python. Okay, so learning the Python and getting into space domain is pretty much connected, people. Yeah. And coming to the next one, this is really interesting. Astronomy and astrophysics. You can include astrodynamics also here. So astronomy. What is this astronomy? Astronomy is all about space survey. Astronomy is all about space survey. How do we start this space survey technically? So we have to find the point of interest at first, region of interest. For example, this space is totally infinity, right? It's very elaborative. You can't just focus into everything all in a particular time. You have to have the proper area of focus. For example, if you want to focus only on Jupiter, you have to focus only on the Jupiter. That itself give you a very lengthy period of research. If you want to focus our Milky Way, you have to focus only on the Milky Way. You have to focus on Proxima Centauri, you have to focus that alone. If you want to focus only on the black hole, you have to start your focus only from there alone. Okay, that is how youngsters should develop their interest towards astronomy. They can't just put their head into everything. They have to have a point of interest. Okay, so once you've located your point of interest, you have to collect the data. Whatever so far people have done related to that, you have to go through the research papers. You have to find the data, whether it's image data or any other format data, binary data, whatever be it. You have to get the data. Usually, when it comes to image data in astronomy, we use the FITS format. FITS, FITS. It's a very specific format. So where we contain the image, contain the data. Okay, you might have heard about the electromagnetic spectrum. That is of different wavelength. So that is how the radiation comes from the deep space objects passed into different group. That is how we collect multi-wavelength data. That's all about astronomy. How to use the space instruments for a point of interest and get the multi-wavelength data and process it, and whatever you find from there, map it to the existing research and showcase your innovation. Okay. That's what people are doing. And this domain is booming like anything. Okay. People are really having a very interest in this theory, in this astronomy, or always thinking about get rid of India and get somewhere. Okay, because they want to have their life in Atlantic or Antarctic somewhere. Okay, this is how people are always hallucinating. Okay, this is really interesting, people. Rather than talking, if you are in that particular field with the space instruments, initially it will mug up. Okay, it will not help. There will be so many calibration errors and lot. But once everything is said, once you start to get the data, and once you start to see the progress in your findings, that's it. You can have your place in a space tech domain. That's all needed. And you need to definitely get yourself into a club. I mean, the group where people are doing collective activities. Now, how come we use the Python here? Okay, how come we use the Python in astronomy and astrophysics? So astrophysics related to astronomy, because we will collect the images. Those images is talking the physics of the deep celestial objects. Based on that physics, whether based on that physics only, we will come to know whether the particular object contains what kind of mineral, whether the water or anything. whether it is in loose motion or gaseous motion, whatever be it. So everything we describe based on the data we collect from the deep space objects through the space instruments. Now the question is, how exactly we use the Python? This is again related to a data, enormous data. So again, we are starting with data extraction. Okay, so we have to introduce Python here because digital image processing is nowadays is all about Python. So we have to know the digital image processing techniques as well as computer vision techniques. Computer vision is related to AI. Digital image processing is powered by Python. So if you know these techniques, if you know these arts, you can play with the image. Initially, the image looks like complete pitch black. After you apply the image processing, it will reveal its hidden secrets. That's how these multi-wavelength images working out normally. Okay. So this is called astronomy and astrophysics, and we use Python here predominantly. And this is one beautiful package, Astropipe package. Okay. So this Astropipe package we use to handle astronomical related data to extract the informations. So for example, there's a fixed image given to you. You are like extracting the content from the fixed image and applying the key functionalities delivered from Astropipe. Then you completely produce a new version of the image. Once again, you provide that image into fixed data and you just port it. You just transport it to other group. This is how the Astropipe project normally working out, people. Okay, and this is really interesting, right? And coming to Python for scientific computing. So what do you mean by scientific computing? Why? So this is nothing but numerical method solving. So why do we need numerical method solving? Coming to physics, coming to aerospace, everything is all about analysis and prediction as well as simulating, right? So this is kind of dealing with physical states, temperature, pressure, okay, and eddies. So this is kind of dealing with that physics and mathematics. So we have to introduce numerical methods solving lot and lot here. So these numerical method functionalities nowadays is delivered from different Python packages. See, SciPy, SymPy, Matplotlib. Matplotlib, ignore the Matplotlib, but SciPy, SymPy is very, very important. So these packages are giving you outstanding functionalities, which is solving the one-dimensional equations, multi-dimensional equation, partial differential equations, entire linear algebra. So these functionalities are solving it. The perfect output we get from there, we are using it in space mission analysis a lot and lot, people. Okay. So Python is already got their hand into it. Then finally, our blockbuster machine learning and AI. Whatever out there in the name of digital, nowadays getting tuned with this intelligence. AI. Everywhere is AI. You might have heard about ChatGPT. You might have heard about Bard, the Mid Journey. What is it doing? Revolutionizing everything. Okay, is our work. We need to be smarter like AI. Okay, so AI is used in spacecraft control systems. AI is used in computer vision. AI is used in NLP applications related to space domain. Robots, take out robots, talking robots. We have robots there in space stations. Those robots' memory is AI. Take out a rover. We have a cameras like more than 20 to 30 cameras are installed in the rovers. So computer vision technology is there. Coming to data transmission, data compression and transmission is also powered by AI. So everywhere we are using the AI, especially in space tech, we are using AI a lot and lot. Okay, and we will do a deep dive about how particularly this machine learning and AI alone used in space tech in the next session. Okay. the next session, people. And yeah, so here, see, I given you some case studies. So these are all the different startups in our, I mean, startups related to space tech established in India recently in this recent decade. And here I listed the specific studies how they are using the Python. See, ISRO uses Python for processing data from satellites and space devices. Astrom uses Python for developing its optical communication payloads. Pixel uses Python for developing its satellite image processing software. Skyroot Aerospace uses Python for developing its launch vehicle software. Launch vehicle software, what is it? Control system optimizer, okay? And Dhruva Space uses Python for developing its satellite bus software, embeddings and IoT. Satsu uses Python for developing its satellite data analytics, okay, data visualization, a beautiful dashboards, that part. And Agnikul Cosmos uses Python for developing its rocket engine control system straight away. They're using it there. Okay, see, already Python is there because it's open source. Okay, you don't have to pay for it. You don't have to pay for its framework. Okay? You just need to sit idle to learn the tactics and produce the produce the product. That's it. Product will be sold in multi-millions. But the effort, the licensing, you don't have to pay anything. It's open source. But coming to MATLAB, it's not an open source. You have to pay them. So there's a difference. For these reasons, people are jumping from MATLAB into Python a lot, especially in developing launch vehicle softwares, rocket engine control softwares. Okay, other domains, satellite image processing, and other domains, embedding systems, we normally don't use like MATLAB. We use some data analytics softwares, right? So this is how Python got its hand everywhere, people. And see, even our startups in India, these are all the huge, I mean, there's all the different number of startups available in India. Okay, see, beautiful companies, okay, established companies, and they are using the Python also. This is the proof. And yeah, we are also competing with the global market. See, 10 top space tech startups to watch in 2023. We are one among them. Okay, we are one among them. It's in Chennai Galaxy I. Okay. Totally, they analyze 774 startups all over the globe, and they really want to look after these startups. These are just startups. I am not mentioning anything about ISRO. I am mentioning about the startups because getting into startup and getting paid and thereby getting like promoted in your life is very, very important, right? So that's all about this. Yes, people, and here I listed out what kind of different roles you would get if you learn Python alone. Okay, definitely when you learn the Python, you have to learn the data science also. If you want to get into remote sensing and GIS domain, and if you learn Python with AI, you can become a machine learning engineer. If you learn Python alone, you can become a software engineer. If you learn Python with the numerical methods and solving, you can become a research scientist. Definitely, when you have good years of experience, you can become a project manager. And coming to deployment and orchestrations, definitely DevOps is required. If you know the Python, you can become here also. And data analyst roles, this domain specific astrodynamic roles, spacecraft system engineer roles. These are all the quite examples, people. This is not the whole examples. Very few examples I shared here. And of course, you need to have Python programming skills. Based on that, you would get data science skills. Based on that, you would get machine learning skills, and entirely you would get software engineering skills. And obviously, when you have these Python data science machine learning skills, you automatically get the research skills as well as project management skills. These are the skills you need. But being an intern, being a fresher, you don't need to worry about anything. But this is how we have to proceed. We have to start from scratch. We have to start from Python. Then we have to slowly get into data science. Then learning the AI. Then learning the few frameworks and the software building, then do some projects by doing some research, and finally, when you are getting some experience, learn how to control the team. That's it. Becoming successful in life. Okay. So this is all about our theoretical part today. Theoretical part today. So before I jump into the code walkthrough, I'm making a stop here for a while. Okay, you can like raise your doubts. I hope you got the complete idea. Let me revise it quickly. We started with we started with introducing the Python, okay, importance of Python, why Python is popular language. Then we checked few companies. Then we had a very, I think, we had a very interesting introduction about space tech applications, how Python is used. Yeah,
नाटे
yeah. Any doubts? Okay. Then I think you need to mute the mic, right? If you're not in concern. Then we discussed this data analysis process. Then is remote sensing stuff. Then space mission data. What is this? And obviously astronomy, astrophysics, Astropipe project. Then Python for scientific computing. Okay. And we ended with machine learning AI. Then we checked different companies and in India, especially, and how they are using the Python there. Then we checked this slide how we are competing with the world in space tech. Then finally we are here, people. Okay. So this is it with my theoretical part. I'll be doing a quick walkthrough about the code part. It will not be a heavy, okay? So any doubts, people? Shall I proceed with the code part? Yeah, time is already 8, right? So I have to hurry. Please tell me any doubts. Okay. Shall I, Arjit? Okay, okay. Okay, guys, so time is already 8 o'clock, so I have to be hurry. I hope you got everything about whatever I discussed in the theoretical part. Okay, guys, so I'm going to show you a simple demo, okay? I'll be a little bit quicker here. So I'm going to import a Galaxy image from this server. So you have to get into this link, okay? That will, open a web page where you have to mention what Galaxy data you want. Okay. This M stands for Messier. NGC stands for New Catalog of Celestial Objects. These are nothing but C illustrations. So I am giving you a default one M42. So it is now opening the data server. Yeah, this is the default image they want to provide. So we are not actually fetching the multi-wavelength fits images. We are fetching the JPEG. So once we got the JPEG about the M42, what this server offers, we are importing that JPEG here in Google Collaboratory in this temporary storage. The file is here. Okay. So now we got the file, what to investigate. Then we are going to fetch the packages, that is matplotlib, sk image, numpy. So we don't need to install these packages in this workspace. It is already installed and optimized. This is Google Collaboratory. This is coming with these packages as default. Once we import the functionalities of these packages, we are using it to read the image. And this is the image, okay? So this image is obviously a numpy array. And looking at the image, what we can predominantly assume, this must be the core, this must be some hot object, this must be some cool object, and this is highly a fabricated image from a space sensing data. Okay, this is a fabricated image. obviously from a space sensing image. But this data is trying to reveal the information about the particular M42 galaxy. Whole galaxy is here, okay? And this image is obviously number arrays, and coming to shape, this is the shape. Totally 1489 is the height of the image. 2048 is the width of the image. 3 is nothing but the band. Okay, it's a colored image, so there will be 3 band, that is red, green, blue. And I'm going to convert the colored image into gray image. Okay, so I have to enable this option as gray equal to true. So this time I'll be getting the gray image. So when I'm checking the shape of the gray image, it's now just 2D. It doesn't have the bands. It's just 2D. Okay, height and width. And this is your gray image. You lost the colored patterns. Okay, that's how the gray image will remove the colored patterns, will give you the gray nature alone. Then this is the image you are going to do the analysis, and you have to carefully check for the distortions and noises at first. So I'm going to remove the noises using Gaussian smoothing. So this is one approach. The very decent statistics is played underneath this Gaussian smoothing. So I'm going to use it through the Python. Everything is Python here, through the Python. For that, I'm going to use the SciPy package, and I'm going to use the functionality convol 2D. Then I'm initializing 2 kernels. One is for a very ordinary kernel. Another one is for a Gaussian kernel. Okay. So this Gaussian kernel is the best one because Gaussian kernel is straight away giving us a Gaussian distribution. Okay. So see how the statistics we are employing here. That way we are creating the kernel. So what do you mean by kernel? Kernel is doing the filtrations on an image, creating a new version of the image. That's all about kernel. So once I declared here ordinary kernel and Gaussian kernel, I am going to call an adapter, that is convol 2D, with a particular kernel. So this is a line of code where I am going to adapt a convol 2D, and I am going to introduce the ordinary kernel, and this is my resultant image after the denoising. Then I am going to adapt the Gaussian kernel, the highly statistics kernel, and this is my resultant image. This one looks good, better than the previous one. So I'm going further with this image, the convolved image, I mean the Gaussian denoised image. So this is the different color map or color themes I'm going to introduce. So I'm introducing the filters straight away. So this filter is known as Sato. I am introducing the filters from SK image, where I am introducing my convolved Gaussian image, and I will be getting the filtered image. Okay, this filtered image I will be looking with these 19 color maps. So after this for loop, after the 19 iterations, you will be witnessing the same image after the filtrations with 19 color maps. Okay. So this is the filtered image with the gray color map. Okay. So now your galaxy core is pretty much obvious. This is your brightest spot, and we are not having the proper information about the coolest part here. And we are here revealing other objects. Okay, 1, 2, 3, 4, and so many objects we are now able to reveal. If we set up some object detection mechanism that will detect how many objects are here in this nebula. Okay, and we also spotted another one brightest object here. This could be a star. Okay, both of these stars could be the young stars, and this is one brightest object. So initially it wasn't done right. When I was looking this image, I wasn't able to get that much information, but now I'm getting pretty much enormous informations. Am I right? Then I'm going to look the same image with a different color theme. Same information I am getting, this time different color theme. This color theme is not working out. Look at this color theme. So this color theme is trying to reveal a different physical state. This is actually talking about the hottest portions. Okay, there's a difference between the color magma and the color blue. The blue shades are indicating the physical state here is entirely different. Okay, so but we are not sure what is this exactly because we didn't know what is this image. This image is a straightforward JPEG. We didn't know anything about in which wavelength this image is related to. If you come to know in which wavelength, automatically there's a notion, there's a concept. Based on that, we can easily figure out what is this different. I mean, what is this difference between this colored portion, these two colors? Okay, that notion we can get. Then, yeah, this is. I mean, this color theme also revealing two states very effectively. Again, this is not doing well. This is doing good, not good. Okay, fine. Okay, okay. Mm-hmm. Not good, not good, because we already got the information what we wanted. So initially, the image was just a fabricated image. It didn't. I mean, we were not able to get these insights. But see, now we are getting these insights. How is this possible? Image processing, and we used Python a lot here. So this is an open session. I am not actually explaining the code. I am just showing this because you can have the proof how in real world Python is used in projects. So I got the only one source. I converted that source into different version of the images. See, here I listed 19 images. How I got the 19 images from the single image with a elaborated insights, image processing, digital image processing. And what's underlying the digital image processing? Statistics. Okay. So how effectively we use the statistics and how we frame the strategy and logics and how we give the algorithm shape through the Python programming. That's all about it, people. The digital image processing. Okay. That is also powered nowadays with Python. So this is a good example how we are using Python in a real world for space tech projects. Okay, and I am done with my part, people here. And I mean, our next open session will be at the next week. We will meet there to discuss how AI ML extensively used in space tech. Okay, extensively used in space tech. Okay, sorry for taking extra 30 minutes. And I guess I did my part. And any doubts, just yeah, the session is yours. You can raise your doubts if you have any. Okay. Once you are done, once I'm done with your doubts, I have to hand over the session to Ajit to wind up. So, do you have any doubts, people? Anything regarding the career opportunities, how to start, the Python, the space tech, regarding this code walkthrough, whatever be it, you please unmute yourself and raise your doubts. Okay, please carry on. Any doubts, people? Yeah, you got it, Rams. Good. Okay, guys, any doubts? Yeah, astro image. Yeah, yeah, of course, of course. Thank you for the info, Rams. Is Python secure in terms of privacy of space data? Space data is crucial. Okay. You know what? Uh, in